Hi, Mr. Khan. How's it going?
Good. I'm sorry. I was sitting here waiting for you to log in, and I forgot I hadn't sent you the number yet. So
Okay.
glad you sent me that. I'm ready. That made me realize that I needed to send you the meeting ID number. So,
Okay, that's all good.
what do we got tonight? You gonna verbalize or send me stuff? Or,
I'm gonna do a little bit of both, but just the usual, pretty much.
okay.
I said a little bit of both, but just the usual math, pretty much.
Okay. Go
So
ahead.
I'm pulling it up right now. I just saw the new Star Wars movie.
Oh yeah, is it any good?
Yeah, I enjoyed it. It was really good telling you the backstory of Han Solo
Uh
and how he started. So that was really
huh.
interesting.
Surprise! It hasn't. It's kind of the first Star Wars movies that they're saying might be a bomb. Uh,
Really? Yeah, that's what I've heard too.
It hasn't done that well at the box office, so
Yeah, I agree. But I personally enjoyed it, if you know what I mean.
well, that's good. No, that's good, especially if you own Disney stock.
Yeah.
Okay.
Alrighty, so the first one I've got is graphing a parabola. So I'll just verbalize it.
Okay.
So it says y equals x squared plus 4x minus 1.
All right.
And it's asking me to plot the vertex and 4 additional points.
Okay. So they want 5 points, which you don't really
Yes.
need. You only need three because 3 points define a parabola, just like 2 points define a straight line. But a lot of teachers do want 5 points. All right. So, a couple of ways we can go here. We can get the x and y coordinate of the vertex, and then we can just figure out the x-intercepts, maybe the y-intercepts, and that'll give us our 5 points. There's another way to do this, which is to put it into vertex format by completing the square. But quite frankly, I think that's actually harder to do. Which one do you know how to do? That's the key. You got to be able to always find the vertex.
The one or the way that I'm comfortable doing is I'm like I just do the normal parent function and then I just go from there.
Well, that's hard to do here.
Yeah, it does look hard in this situation. The other ones
Well,
I'll be able to do it,
you
but I
can't
can't see
really
it.
you can't use that technique here. Now you could do you could make up 5 values for x and plot 5 points on the graph, but unfortunately that wouldn't give you the vertex. So we really have to get the vertex. There's two ways to get the vertex. I'm not sure which one you use the most. Um, the x, this to me is the easiest way. The x coordinate of the vertex is minus b over 2a, which you will notice is the first half of the quadratic formula, right? Quadratic formula is minus b plus or minus square root of b squared minus 4ac all over 2a. So if you were to separate
Mm-hmm.
two fractions, this would be the first half. Okay. So what's the x-coordinate of the vertex?
Would it be 1?
Let's see.
Or what 4? Would it be 4, actually?
Okay. First of all, what's minus b?
Minus b would be negative 4.
What's a?
A will be 2.
No. A is the coefficient of the x squared term.
Okay, so that would be 1, and then times the 2,
All right.
which would be
So
2.
that is negative 2. So I know that my axis of symmetry runs down the line x equal minus 2. Okay? And that's a good starting spot. What's the next thing I need to do?
To plot the y coordinate.
Okay, so what is the y coordinate of the vertex?
Would it be -1?
No, well, the way you get it is by plugging it in. The x, in other words, remember that at the vertex, the x coordinate and the y coordinate are on the same point.
Mm-hmm.
So the y coordinate is going to be minus 2 squared
Plus 4 times -2.
minus 2 minus 1. Well, that's 4 minus 8 minus 1, -5. Okay? So,
Okay.
we'll call that the vertex right there. Minus 2 minus 5. Now what? First of all, I'm going to erase all this stuff because we don't need it anymore.
Okay.
How do I get my other they weren't specific, they just want 4 other points?
Yes.
Okay.
2 on each side of the vertex.
Does this go up or down?
This one will be going upwards.
About the easiest number to come up with is the y-intercept. What is that?
What do you mean by that?
Well, if I draw this parabola, it's going to look something like that. What's that point right there?
That would be the y-intercept.
What is it? It's real easy to figure out. Much easier. What's the x value when you're on the y-intercept?
It would be -2.
No. What's the x value when I'm on
0,
the
0. It's always 0. Yeah, it's always 0.
Okay, so what is this point?
So that point would be 0, comma. I'm trying to think of what it would be. Oh, so I would plug that in for the y coordinate. So
Not the
0,
y.
0.
Plug it in for the x. X is worth 0.
So it'd be -1.
Okay. In other words, that's why it's the easiest one to get. Because it's always the constant. The y-intercept is always the constant on the graph. Okay? Now that we have that point, what's that point right there? Based on symmetry.
So it's going to have the y coordinate of -1 as well.
Mm-hmm.
And it's going to be 2.
No, based on symmetry.
Oh, -4, I mean.
There you go. Okay, that's 3 points. Now, these would be the most likely other 2 points to get. But to get those, I've got to set y equal to 0. And then I got to plug it into the quadratic formula to come up with those 2 numbers. So, if they weren't specific in which 5 points they want,
it can be any.
Well, then let's make up an easier one. Rather than having to solve this quadratic using the quadratic formula, what's a better couple of points to use?
To be honest, I have no idea.
About x equal 1. What's y equal when x equals 1?
So that would be 1 plus 4. So 5 minus 1, which would be 4.
Okay. So if I go over to here, somewhere along here is a point that is x equal 1. Y, would you say 4?
Yes, I said 4.
Okay. So there's a 4th point. Now, we can use symmetry to figure out this point also. And that's the easiest way to do it. We know the y-coordinate's the same. What's the x-coordinate?
So in comparison, I would add 1 to it. So it would be -3.
What's this distance right here?
That is 1.
No, it isn't.
So negative.
No, hold on. It's not 1. I'm going from -2 to 1. What's that distance?
Oh, so that would be 3 spaces.
Okay. So it's got to be 3 units to the other side.
To the left.
Why?
So -3.
-3. And it's got to be 3 spaces from -2.
So then that would be -5.
You see why? In other words, if that's 3 units right there, well, then that's 3 units. And if that's 3 units to the left of -2 is -5.
Okay, since I was thinking about 0, but I see the -2 that we're counting away from.
Yeah, it's always good when you're graphing a parabola, especially one like this that doesn't factor nicely. Always draw your line of symmetry in there because that helps put your other points on there. Because it is symmetrical about the line of symmetry. It is not symmetrical about the y-axis. It's only symmetrical about the line of symmetry. All right.
Gotcha.
Now, I could have solved for these x-intercepts, and most of the time they want to know that. They want to know that point, and they want to know that point. And if I had to do that, then I would have to set that whole thing equal to 0, because that's where the x-intercepts come, is when y is 0. Then I'd have to use the quadratic formula, and I would get irrational answers, which are fine, but it's harder to do. So if they didn't ask for the x-intercepts, we're not going to do it the hard way.
That's the best way to do it.
Yeah, always the easiest way for sure. What else you got, Taylor?
So the next one says find the x-intercepts and the coordinates of the vertex for the parabola of y equals x squared minus 4x minus 12.
Okay. First of all, is that factorable?
X plus, or it looks like it. Yes.
Yes.
So x minus 6 and x plus 2.
Yeah, and that helps because there's our x-intercepts immediately.
So that would be 6 and -2.
So, how about a y-intercept?
And so for the y-intercept, would I just put
Always that constant. Because it always comes when x is 0. And when x is 0, these first two terms disappear. So it's always the constant.
Okay, so it'd be -12.
Uh-huh.
Gotcha. So it's always pretty much the c value.
It is always the c value. Not pretty much, but okay.
Okay.
Now, I can figure out the vertex if I got a line of symmetry. Do we know the line of symmetry? That's -2. That's +6. What is the equation of that line right there?
Okay, so that would be, so -2 and 6 are my two values, so in between those, so 0 and 4? Or no.
No, you're right. 4, no,
Oh, okay.
4 is not the correct value. When
Yeah.
you're trying to find a number that's halfway between two numbers, just add the two numbers and divide by 2.
Okay, so the positive 6 and the negative 2. So that would be 4. And divide by 2 is 2.
Notice that 2 is halfway between that. It's 4 units from negative 2, and it's 4 units from 6.
Correct. So it would be 2 and 0.
Yeah, so now I have a lot. In fact, the only thing I am missing is the y coordinate of the vertex. So what is the y coordinate of the vertex? I know what the x coordinate is. It's 2.
Mm-hmm. Would it be 0?
No, you got to plug in the x coordinate into the function.
Okay, so 2 squared is 4 minus 8. So 4 minus 8 minus 12. So negative 4 and negative 12 is negative 16.
Okay, so the vertex comes at 2, negative 16. Okay, and now I know how to graph it. Now, what did they ask for specifically?
Just the x-intercepts and the vertex.
Okay, well, there's our x-intercepts, there's our vertex. We didn't even need this other point here, the y-intercept. But the y-intercept is always really easy, obviously. It's always the constant.
Mm-hmm.
So, if they needed a fifth point, we can figure out that that point right there is symmetrical with this point, just an equal distance on the other side of that line of symmetry.
Okay.
All right. What else you got?
The next one I have is answer the questions below about the quadratic function. So the function is g of x equals 3x squared plus 30x plus 73. And then it says, does the function have a minimum or maximum? Where does the minimum and maximum occur? And what is the value of the minimum or maximum?
Okay. What's the shape of this thing?
It's going to be a parabola, and it's going to be having a minimum because it's going to go infinity upwards.
It opens up. So I don't know what it looks like, but let's see. I do know it goes through 73. So we'll assume it looks something like this, where that's
Okay.
0,73. So you're right. By the fact that it opens upwards, we're looking at a minimum. So what are they really asking for?
I guess like the lowest point of the parabola.
What is that? What's this point called?
Would it be the vertex?
Yeah, that's all they're asking for is the vertex, the x and the y coordinate. The absolute minimum value is going to be the y coordinate of that vertex, and it's going to come when x hits that value right there. So how do we get the vertex? That'll answer all the questions, or read all the questions to me.
Where does the minimum or maximum occur on x? And what is the function's minimum or maximum value?
And what that is the x and the y coordinate of the vertex is what they're asking for. So let's go through it. What is the x coordinate of the vertex? General formula.
Okay, so would we just zero out everything again?
No.
Or do we do the quadratic formula?
No.
Negative
minus b over 2a. Don't forget this. This is the easiest way to get the vertex in many situations.
Okay, I'm writing that down.
Minus b over 2a. Remember, it's just the first half of the quadratic. When you have a quadratic, you get this. Minus b plus or minus square root of b squared minus 4ac all over 2a. That's what I call the first half of the quadratic.
Okay.
Because you can always split these fractions up. In other words, I could say x is equal to minus b over 2a plus or minus all of this over 2a.
Mm-hmm.
So just remember, the x coordinate of the vertex is always the first half of that quadratic. So what is it here?
So on this one, it would be negative 30 over 3 times 2, and that's 6. So that'd be negative 5.
So this occurs at negative 5. Now, what is the y value at negative 5? In other words, what is this y value?
Okay, so then I would put negative 5 in for x.
Mm-hmm.
So that would be 5 squared, which is 25, times 3 is 75.
I tell you what,
And
I cannot overemphasize the need to do it the way I'm doing it right now.
okay.
Just because you won't make any mistakes. If you do this stuff in your head, you're bound to make more mistakes. So that looks like negative 2.
It appears so.
So
Yeah, it would be negative 2.
that's the answer. That's the minimum. The minimum value, in other words, the minimum on the range is negative 2. You can get the negative 2 on the downside, that's it. And it occurs when x is negative 5.
Okay. That was pretty simple.
Yeah, that's why they stress so much importance on the vertex, is because it answers those questions. Because frequently, when you're looking for maximums or minimums of a quadratic, there's only one. It's either a minimum or a maximum, and it always is at the vertex.
Mm-hmm.
That's why we have 8 different ways to find the vertex.
Gotcha.
You only need to really remember that one. Minus b over 2a, and then take whatever you get, plug it into the function, and you get the y coordinate of the vertex.
Okay. Now I got some more that kind of gave me a little bit of trouble. So for this one, it's using like composite functions.
Okay.
And so I'll give you f of x equals square root of 2x plus 12. Then I have g of x equals x minus 3.
It's the first thing they want.
So the first thing they'd like is f of g and then parentheses x. And then they want the domain of f of g.
All right, that's how you write that. That's f of, instead of x, it's f of g of x.
Mm-hmm.
Okay. If I said, what's f of 2? What would you do?
I would put 2 in for each of the x's in the f function.
Okay, so you get the square root of 16, right?
Correct.
Okay. So when they say f of g of x, instead of g of x, let's put in what g of x is, x minus 3. Now, how do I get f of x minus 3?
So I would do like the distribution of 2 outside of the x minus 3 and then add 12 with the square root around it.
In other words, the secret is whatever is in the parentheses is what gets substituted for x in the f function. So
Correct.
the square root of 2 times x minus 3 in parentheses, and always do this in 2 steps also. And now that gives you 2x minus 6 plus 12, 2x plus 6. That is fog.
Okay. And then I just can leave it that way?
Yeah, there's nothing you can really do to simplify that. In other words, that is f of g of x and there's nothing you can do to that.
So lastly, I just need the domain.
Oh, sorry. What is the domain on our composite function? How do I get it? What I've circled is the composite function.
Square root of 2x plus 6.
What's that?
Yeah, it's the square root of 2x plus 6.
Right. How do I figure out the domain from this?
Look at what would make it 0.
No, look at what would make it greater than or equal to 0. That's what it has to be. X doesn't have to be greater than 0. What is inside the radical sign has to be greater than 0. Greater than or equal to 0.
So negative 3.
So X is greater than or equal to negative 3. However, when you are dealing with composite functions, you always have to go with the most restrictive domain. So you don't look at the domain of your final answer only. You also look at the domain of each of the original functions. What's the domain of f?
That would be negative 6.
What's the domain of g?
3.
Oh, gx can be all real numbers.
Oh, actually, yeah, you're right. Yeah.
So,
since it's not a square root of anything.
Out the domain of our final answer, it's the more restrictive domain. It's more restrictive. Excuse me. This is more restrictive. I'm sorry, I got it wrong. In other words, if I'm giving the domain of my final answer, it is bracket, excuse me, negative infinity, I'll get it, negative 3 to infinity with brackets around the negative 3. That is the domain of our composite function. In other words, it really cannot be minus 4, minus 5, or minus 6. F of x could be. F of x can be minus 6 to infinity. But of the composite function, clearly we can't be minus 4, otherwise we'd be taking the square root of a negative number.
Which is hard.
When you're dealing with composite functions, just remember you've got to figure out the domain of each of the original functions and the domain of the composite function and use the most restrictive, in other words, the narrowest.
Okay.
This is more restrictive than this. This allows 3 more numbers, minus 4, minus 5, and minus 6. This does not allow those.
Okay.
Any more on these two functions?
Nope, that's all for those two. Okay, so the next one I have is, I think I'd rather send a picture of this to you.
Okay.
Just because there's a lot of stuff on here.
Tell me when you've sent it, when it says file sent.
Now it said file sent.
Say file sent, or is it? There it is. Can you read that okay? I can make it out, I think.
Yep, I got it on my screen too.
Okay, awesome. So here we have, let's see, for each pair of functions, find f of g of x and g of f of x. then determine whether they're inverses of one another. Okay, so the first one. Here, let me go ahead and let me write this up here. F of x equals 3 over x, and g of x equals 3 over x. What is f of g of x? And do it step by step.
Okay, so I'd have to put the 3 of x into the x position. So it'd be 3 over 3 of x.
Okay, use your terminology. This is f of 3 over x, which is going to be 3 over x, which is going to be x over 9. So that's fog, x over 9.
Okay.
Now, let's figure out g of f of x.
I would do the same thing.
Yeah, they made the two functions the same, so this is fairly easy. Now, is one a inverse of the other?
I forgot how to do the inverse of these.
When you take fog or goth, it has to come out to be x. If it comes out to be x, it's an inverse. This does not. This comes out to be x over 9. So these two functions are not inverses of one another. For it to be an inverse, this would have to be x, and that would have to equal x. That's the definition of inverse.
Okay.
So that answer right there. Okay. Other two functions. Let's see. I'll use more of the paper here. F of x equals negative x minus 4 or plus 4?
1 second. Let me pull it back up. F of x equals negative x plus 4, and then x plus 4. For g of x is x plus 4, but then f of x is negative x plus 4.
Okay. So what is fog?
So for that one, I would have to do f of x plus 4. And that would equal negative x plus 4 plus 4.
Use parentheses, because you're always going to be using parentheses.
Okay. So parentheses, negative.
No, that's
No,
negative.
the negative, then the parentheses. X plus 4, close parentheses, then plus 4.
See why you always need to use those parentheses? Because you're going to get it wrong otherwise. In other words, without the parentheses, that becomes minus x plus 8. But with the parentheses, it becomes minus x.
And that would be it.
No, they're not inverses. Remember, it's got to be equal to x, not minus x.
Gotcha.
So that is definitely fog. Now let's figure out goth.
So it would be g of x plus 4.
No.
Or oops, yeah, g of negative x plus 4, I mean. So I would do parenthesis negative x plus 4, close parenthesis plus 4.
Okay.
So that'd be negative x plus 8.
Okay, that's Goff, but again, they're not inverses of one another.
So both of them are inverses.
Both have to be x. That's the only thing that makes them inverses of one another. For example, if I had f of x equals x squared and g of x equals square root of x, then Goff would be f of square root of x, which is square root of x quantity squared, which is x. Those are inverses of one another, those two original functions.
I see.
Notice the domain of the Goff is all real numbers, but the domain of g of x is only positive numbers, or numbers greater than or equal to 0. So the domain would be that restriction right there. Even though my Goff or Fog, both of them end up being x, which doesn't appear to be restricted, but it is.
Okay. Yeah, I don't think I have to find the domain on this one.
No, I just using it as another example where you can't just look at the final function and calculate the domain. You have to consider the domain of all three and go from there.
Okay, just as a step to make sure.
Yeah.
So the next one I'm going to email you as well.
Okay.
Just sent it.
When they say they're one-to-one, what does that mean?
Putting in 1 into the function of h of the inverse of h, and then put 1 into it.
No.
And for the x, I think.
Here's what it means. Hold on a second. I forgot. You know how to tell if something is a function, right?
I believe so.
What's it got to do to be a function?
I'm asked to pass the horizontal line test.
On the vertical line test.
Or vertical line test, okay.
That passes the vertical line test. No matter where I draw a vertical line, I only get one value of y. Well, for a function to be one-to-one, it's got to pass a vertical and a horizontal line test. So is this parabola one-to-one?
No.
No, it isn't. It does not pass the horizontal.
It'll pass 2 horizontally.
Yeah, so a parabola is not one-to-one. But if I were to draw y equal x cubed, that is one-to-one. In other words, that passes both vertical line and horizontal line tests. That makes it one-to-one, and it also means there is an inverse. Notice that my first function that I drew, the parabola, that doesn't have an inverse. If I were to draw that inverse, I would get this. And that's not a function. So when you're talking about inverses, they have to be functions. And that is a relation. That does not pass the vertical line test because my original one didn't pass the horizontal line test. So one-to-one means that it's going to pass the vertical and horizontal, and it's going to have an inverse, for sure. Well, let's see. I've got G equal those 4 points, and H equals that function. They're both 1 to 1. If I take the first one and I graph those 4 points, there's one, there's another, there's the third, and there's the fourth. And you can, even though you're only looking at 4 data points, you know it's 1 to 1. If you don't know, then just put a curve through those points. You don't need to put a curve. It's not a continuous function. It's only the 4 points I put on there.
And then it stops.
And it stops. Yeah, I apologize. That's not the thing to do. Actually, when you draw a curve through there, it doesn't look like it's 1 to 1. So don't draw a curve through there. The fact is that what makes it 1 to 1 is the fact that for every value of x given, there's only one value of y. And for every value of y, there's only one value of x. That's what makes it 1 to 1.
I see.
Now, they want G inverse is what?
So G inverse
G
itself.
inverse of -2.
So it would be 9.
Very good. In other words, normally if they said G of 2, it would be, we would look for 2 on the x-axis and figure out the y value, right? But
Correct.
when they say G inverse of
You flip them.
-2, you flip the x and y values. So now we're looking for a y value that says -2, and they want to know the x value associated with that point. So 9 is correct there. And then they want, what's the next thing say? H inverse of x.
Yes.
Okay. So if h of x equals 3x minus 14, how do we find inverses? What's the easy way?
I'm used to doing it just with the plots of the what's the name, the two numbers.
It's a simple two-step process. You switch the variables and you solve for y.
Oh, okay, now I remember it. Okay, now I have my memory
I
back.
just had to jog your memory. So, and instead of
So it'd be
calling
x
it
equals
x,
3y
you gotta
minus
call it y.
14.
In other words, if I'm going to switch, I can't, there's actually 3 steps. You got to turn the function notation into y notation.
Yep.
Then you switch the variables and you solve for y. So what's y equal to?
So y will equal to add 14 to the left side, then divide everything by 3. So x plus 14 over 3 equals y.
And that is h inverse of x. Well, I wouldn't really have to introduce y. It's just that most people, that's what they remember. You just switch the x and the y and you solve for y. I could switch h of x with x and solve then for h of x, which would then be h inverse of x. So I don't have to introduce the y. It's just people remember it a little bit more easily.
Gotcha.
And the last one here, does that say what?
h of h net what's name? H of inverse of h and then 1.
What does that say right there? What's that symbol between the H and the... It looks like K.
Would that be of?
Oh, no, that's H. Huh.
Yeah, would that be of?
It's H of inverse H.
Of h. So the inverse is x plus 14 over 3 that I'd have to put into h.
Well...
Or I would have to put in the 1 first into the inverse, right?
What's this always? What's the definition of inverses?
You just flip them?
No. That's how you calculate the inverse. But if I give you functions and I say to you, how can you tell if they're inverses of one another? You could do it the hard way, which is to solve for the inverse and see if it's the other function.
It would have to equal x.
There you go. So without knowing, this, by definition, is x.
So then 1 of x is 1.
Well, it's x of, yeah, in other words, yeah, if I put a 1 in there instead of the x, then I put the 1 in there. So the answer is 1.
So it should always be whatever is in that parenthesis.
Yes. Whenever you're taking...
Oh, that's easy.
Yeah, it is. And that's why they gave you that problem. Whenever you're doing a function of its inverse, you know that's always x, regardless of what the inverse is.
Okay, gotcha.
Okay. Got about
I'm pulling up the next one.
10 minutes. You say you can verbalize the next one, or you sending it?
I can verbalize it.
Okay.
So I got this one. So h of x equals 2x minus 1 over 3x plus 7. And then it says find the inverse of h, find the domain of the inverse of h, and find the range of the inverse of h.
Okay. So let's find the inverse first.
Okay, so I'm going to have to switch the terms. So it'd be x equals 2y minus 1 over 3y plus 7. Then I'm going to have to multiply both sides by 3y plus 7. So it would be 3xy plus 7x equals 2y minus 1.
Here's the...
So then I want to move the plus 1 to the left side.
What's the key step here, the next step?
Actually, I'm going to have to get rid of the y's.
You want to gather every term that has y together on one side, and every term that doesn't have y on the other side.
So minus 7x and minus 2y.
Yes. So you end up with 3xy minus 2y equals minus 7x minus 1. The reason is that we're solving for y. So I got to get everything with a y in it on one side. Now what? These are the hardest steps.
Now take out y on the left side.
Yeah, factor it. Always ends up being a factoring problem at this point.
So 3x minus 2 equals negative 7x minus 1.
No, y times 3x minus 2 equals minus 7x. So y equals minus 7x minus 1 divided by 3x minus
x minus 2.
Okay, so there's our inverse function. Now, they want the domain and the range of both.
Yes.
It's the domain of h of x.
Okay, so for the domain, is that just 0 on the top, or is it the bottom?
Well, which is it? What's your
I
restriction?
think the bottom. The bottom.
Okay, so what can the bottom not be?
-2.
The bottom cannot, the denominator cannot be 0.
Okay. So would I put 0 in for x, or would I equal it to 0?
And the inverse function. Both of them's denominator cannot be 0. That's the only thing you have to figure out. In other words, 3x plus 7 cannot be equal to 0, which means x cannot be equal to minus 7/3. So that's the domain for h of x. All real numbers except not negative 7/3. You know how to put that in interval notation?
Yes.
Okay. What's the domain on the inverse?
2/3.
X cannot be, so it's all real numbers except 2/3. Now, range.
So for that,
First of all, what kind of function is that? What's it going to look like? Not a straight line. It's not a parabola. What is it?
would it be like the hook to the
Hyperbola.
a hyperbola? Okay.
Hyperbola. Whenever you get a quotient like this, it's going to be hyperbolic in nature. And it doesn't matter whether your bottom is x squared or x, but it's going to have an appearance like this. Okay? Now, I've got a vertical asymptote at minus 7/3, so my grid goes like that. And I have a horizontal asymptote at y equal 1. You see what? Excuse me. At y equal 2/3. And I'm talking about only this function for the moment. Because the domain and range is going to be different on these. Although actually, they're just going to be reversed. So, in other words, there's going to be an easy way to do this, and that is to find the domain and range on h of x, and then on h inverse, they're just opposite.
So I'd just flip it.
Well, yeah, which saves us a lot of trouble from having to go through all of that. In other words, dealing with the inverse. But the fact of the matter is if I go back here and I look at my grid for h of x, well, I know how hyperbolic functions look. They're asymptotic to your grid, right?
Yeah.
So the domain on that is everything except minus 7/3. And what's the range? Read it from the graph.
So the range would be -infinity to -7/3.
No, now make your eyes go up and down, not left and right.
Okay. So we're starting off at -infinity.
Okay.
And we're going up to, where would that line stop?
That horizontal line is 2/3.
Okay, so it'd go to 2/3.
The horizontal asymptote is the ratio of those two coefficients. That's where I got it from.
Okay, so if I just do that, that'll work.
Yep. So the I'm going to give it to you. The short version, the domain is all real numbers except minus 7/3, and the range is all real numbers except 2/3. And on this inverse function over here, we can see that the domain is all real numbers except 2/3. What do you suppose the range is?
All real numbers except 7/3.
Negative 7/3.
Negative 7/3.
Yeah. So you just switch them. In other words,
So
once
would
you
it still
have
be
the
the same?
domain and range of a function, you have the domain and range of its inverse also. It's just switched.
Okay.
The same reason you switched those x and y values in that previous function that just had 4 points.
Gotcha. That's not too bad.
No. And that's a key thing to remember about domain and ranges with inverse functions, is they're just opposite or switched with one another. All right.
Well, thank you for the help.
You're welcome. So are you taking like a summer course? I was thinking the last appointment was probably the last before a final, but...
No, summer courses for another 2 more weeks, and then I'm done.
Okay.
Yeah, so I'm going to be finishing my sophomore year, and I'm going to be a junior.
Okay, well, good for you. Good for you.
Thank you. You have been taking a lot of classes.
Yeah. No, if I can be of further assistance, just let me know.
Of course, I'll contact you. Thank you for the help, Mr. Cowan. I'll see you soon.
You're welcome. Bye-bye.